Welcome to EDU World Space.
Okay, so this problem is about the lens of the eye. And so it's a double convex lens. So I'll go ahead and draw it like this. And it has an index of refraction of 1.44. So n is equal to 1.44. And the focal length is 8 millimeters. So 8. Oops. And the radius of curvature has the same magnitude. And then we want to find the radius of curvature of the lens. So to do that, we can use our equation, the lens equation, which is 1 over f is equal to n minus 1 times 1 over r1, not plus, minus 1 over r2. And so these are the same. So that's going to be n minus 1 all multiplied by 2 over r. And so if we want to solve for r, we get that that's equal to f times n minus 1. That's minus times 2. So I'm going to go ahead and plug that into a calculator. Let's see, 16 times 0.44. So that's 7.04 millimeters. Okay, and then what else does the question ask? If the object is placed, so we know that the object is 16 centimeters tall. I'm going to do this on another page. Y is 16 centimeters, and we know that its position is 30 centimeters. So S is equal to 30 centimeters, and we basically just want to know where it's focused and how tall the image would be. And so the F is equal to 8 millimeters. So I'll go ahead and transpose that here. So F is equal to it was 0.8 millimeters. No, 8 millimeters. So that's 0.8 centimeters. And okay, great. So now I can use the thin lens equation to get S prime, the position of the image. So we know 1 over S plus 1 over S prime is equal to 1 over F. So we get that 1 over S prime. Bring this to the other side, add the fractions, and then cross multiply or some other version of that algebra will give you F times S divided by F minus S. Did I do that in my head right? Oh, whoops. To the S prime equals, bring that over S. Wait, it would be 1 over F. I'm just going to rewrite it out. Having trouble visualizing it. So 1 over S prime equals 1 over F minus 1 over S. And then, yeah, then it would be S minus F and then flip it. Okay, so I was wrong down here. So that's going to be S minus F. Great. And plugging in F and S, is this something I can do in my head? No, I can't. Okay. 30 times 0.8 divided by 29.2. I get 1.25. centimeters. So that's where the image gets focused. And it makes sense that it's such a short distance because it needs to reach your cornea to go to your brain. And so now we want to get the height of the image. So we can do y over y prime equals minus, this should be s prime over s. Or excuse me, y prime over y. Redo this. I'll go ahead and block this off. Now we're trying to find the height. So s prime, negative s prime over s equals y prime over y. And y prime is therefore y times s prime, don't forget the negative, divided by s. So I'm going to plug that into a calculator. Okay, 1.25 divided by 30. And then we want to multiply it by the height of the original, which is 16. And then that means that the image height is 0.667 centimeters. Okay, let's see. I'm getting different answers. I'm going to pause this and reinvestigate. Okay, I made a calculator error when I calculated s prime. So let me go ahead and fix that. It was just a calculator error. So if I recalculate it, I get 0.822 centimeters. And then if I go ahead and redo this calculation, let's see what I get. So 0.822 divided by 30 multiplied by 16. I get 0.438 centimeters. So let me revise that. Great. And what else is asked? So that's the height. And then if s prime is positive, the image is real. I guess I think it would have to be real. Like the photons would really have to focus on your cornea, or I think that's the right part of the eye. The photons would have to focus to create an image that your mind could read. And so is it inverted? So magnification is negative s over s prime, and s and s prime are both positive, and therefore the magnification is negative, and therefore it's inverted. So I'll go ahead and write that down. So it's inverted. And I'm going to pause this real fast. Okay, yeah, I stand by my answers. I was just double checking everything.